Hi everyone, and welcome back to the channel. It has been a pleasure having you once again. Today we are continuing with the part 1B of our lesson or studies on the foundations of electricity. In the previous video, we talked on static electricity, where we established the fact that in static electricity, there is no continuous flow of electrons. And as a result, electrons tend to build up on the surface of the object. And then we look at some examples of static electricity as rubbing a balloon on our hairs, where the hair transfers electrons to the balloon, making the hair positively charged and the balloon negatively charged. So it enables the balloon to be able to get attracted to the hair. And we also talk on the friction between the socks and the carpet. And then we also talk on the natural phenomenon lightning that occurs when it's about to rain. That there is a buildup of what static electrons in the clouds, which then jump to the ground. So today we are continuing with the part 1B. If you haven't watched the part 1A, please, I encourage you to watch that video before moving to this one. Thank you. So today, what are we to learn? Today we are coming to look at what we call current electricity, the opposite of static electricity. So we are going to look at what current electricity is and why it flows. So let's dive in right away. What then is current electricity? Current electricity is a type of flow of electrons or electric charges through a material. So unlike static electricity, current electricity is different because there is a continuous flow of electrons through a conductor, like a wire, as you can see here. There is a conductor here, a wire, as you can see here. So imagine you have batteries connected. Okay, these are batteries connected to a wire and then to a bulb with a switch. Okay, so we have the, how do you call it, the positive terminal, and then we have the negative terminal. So we have the negative, which is minus, and then we have the positive, which is plus. So electrons flow from the negative terminal through the wire and return to the positive terminal. Okay, and this flow helps to light the bulb that we can see here. So electrons move from negative terminal and then it moves through the wire, then back to the positive terminal. And as a result of this flow, it helps our bulb to light up. And if the circuit is broken when the switch is open, there will not be any electrons flow. So electrons will stop moving and the bulb will go off. And if the circuit is complete or the switch is closed, electrons flow continuously. The bulb stays on. So this is what we have to understand, that the moving electrons carries energy, which is what helps to power the device, in this case, the bulb. So the key things you have to carry on in this particular lesson or here is that current electricity requires a path and a voltage difference, which we'll be diving into in our next slide. It requires what? A path and a voltage difference. And then it is used in all electric devices, from light to computers, fan, motors, among others. So this is the concept of current electricity. it doesn't flow in a static way. It should have a continuous pathway. In this case, a power from the battery move through the wire and then close with a switch helps our items or devices to light up. This is the idea of current electricity. So why does electricity flows? This is the major reason I want us to understand here. I mentioned earlier potential difference, and this is exactly where we have to understand this. Friends, electricity flows because there is a difference in the number of electrons between 2 points in here called the potential difference or the voltage. So before an electric current will flow, there should be a movement between 2 points. There should be a current flow between a higher concentration to a lower concentration. If there is nothing like this, electrons will never flow. So think of a water tank, okay? We have a water tank in the home. Think of it. Now, water flows from higher level to the low level due to what? Gravity. So you having a water tank in your house, you know that when a water want to descend, most of the time some of us use polytank and then connect pipes to it to descend or help in the flow of water to our various homes. Brethren, if this does not happen, water will never flow. So we understand that with this force of gravity helps the water to be decentralized or shared in an easy way. The same manner when it comes to the flow of electrons, there should be a high and a low level for it to flow. So if electrons move from areas of many electrons, okay, this negative side, the electrons are very high here, and then which is negatively charged. So it has to move to the area with few electrons, which is positively charged. And as it goes there, the concentration reduces. The same manner when water is flowing from a tank, it comes with a high speed from the tank, but as it moves down, the speed reduces. That is the same thing that happens in this particular flow of electrons in a current electricity. So voltage is the push that makes electrons what? Move. So the bigger the voltage, the stronger the flow. And if there is no voltage difference, electricity cannot flow. So if there is no high concentration to low concentration, if electrons does not move from the negative charges to the positive side, there is no way electrons will flow or electric current will be generated. So just like water cannot flow without a slope, it's the same way electrons or electricity current or current electricity cannot flow without those two or potential difference. So this is very important for us to understand. Potential difference is basically the high concentration to the low concentration movement of the charges, meaning that it's moving from a region where the electrons are high to a region where the electrons are few. And when the electrons are high, we said they are negatively charged area or point. And moving to where the electrons are few, we say they are positively charged electrons. So you can see the wire in here. So this is the wire where the black thing that we are seeing, this is the wire, okay? This whole thing is the wire where the electrons are moving from this direction to this direction, as you can see in the arrow. I hope we are getting this particular studies clearly. All right, so let's look at some examples of electricity so far, what we have done in the part 1A and the part 1B. We talk about static example, balloon wrapped on our hair, the charges move, the hair sticks. Okay? And then we talk about lightning, a static electricity jams from the clouds to the ground. And then in the current, we talk about a wire to a battery where the bulb light. So these are the things that we look at so far in our studies in the part 1A and the part 2, part 1B. Notice that static electricity is built up and stationary until it discharges. But current electricity flows continuously through a circuit. And these examples show how electricity works in different ways and why it is so important in our daily life. All right. So to summarize, I want us to look at the fact that electricity comes from charges, both positive and negative charges. And in static electricity, it's always stationary. Current electricity, there is a continuous flow of electrons. Electrons move because of charge differences and voltage, meaning it moves because there is a high level moving it to the low level. The high level is the electrons, the negatively charged part, moving to the low level, which is the positively charged part. So this is what helps electric current or electrons to what? To flow. And we also look at some everyday examples that we use: balloons, socks, we use the lightning, and then we also talk about the light bulbs, and then our other devices. Understanding this concept, brethren, friends, is essential because we move, we use these things in our daily lives. And then as we move to the next part, which is part 2, it is going to be simple, because in part 2, we're going to talk about electric current and simple circuits, where we will build circuits and explore voltage, current, and then resistance in action. So this has been an interesting lesson and a wonderful one, of course. And I believe that you had a clearer understanding on the subject of electricity. If you enjoyed this lesson, I encourage you to like, subscribe, and turn on the notification bell so you don't miss the part 2 of this lesson on electric current and simple circuit. And until we meet again, stay blessed, keep learning, and God be with you. Bye-bye.